Hi, everybody. So I guess we'll get started. It's 11:05. We were just given a couple minutes for anyone else to log on, but we are going to be recording this video. I think Mohsen and Carole, it's already recording, it seems. So I think we're good. Okay, so I'm going to go ahead and share screen, and I'll let you. We'll start the presentation. Okay, so welcome again. My name is Dr. Ed Bednarz. I'm here with two of my colleagues from the mechanical engineering departments. I have Dr. Mohsen Ghamari and Dr. Carole Baddour, and they're going to be taking turns kind of sharing some information as we go. So our goal is to present for about a half hour, and if there's any questions at the end, you could just chime in, raise your hand via Zoom or the virtual chat or however. Our goal is just to answer any questions you have, and really we're proud working at Wilkes, and we want to showcase all the wonderful things we do here. So here's our brief agenda for this morning. First, we're going to start out with why mechanical engineering, and then that kind of leads into, well, why Wilkes? What do we do well compared to other schools? We're going to talk about our curriculum, our faculty and staff, our facilities and research, our co-ops and senior projects internships, integrity and community, and we're going to open up for some questions at the end. So first section, why mechanical engineering? So you want to be an engineer, and we thought we'd start out with something a little funny here. Physics conference, are things made of stuff? Philosophy conference is stuff. Engineering conference, awesome stuff. Gonna be more awesome. We're gonna put a giant laser and ultra space jets. But truly, like it's kind of a joke slide, but it's the truth. Myself and all my colleagues, we enjoy what we do. We enjoy the field of engineering. That you're taking something out of nothing and you're creating it, and you're helping people with their lives. So it's a great field. So not only is it a fun field, but it's also financially rewarding. So I know as parents, and I'm a parent myself, 4 children, that you want your child to succeed, and you want them to have a comfortable lifestyle. Not that money is everything, but you don't want them struggling to put food on the table. And engineering is a very lucrative profession. Maybe the average person doesn't know that, but whenever the average person thinks of high-paying professions, they may think of doctors, lawyers. But check out the median salary for mechanical engineers. Nationwide, it's $83,000. So, it's pretty good salary, and even for this area, students are making 50, 60 right out of school. So, really that's great for this area. How about the job growth? We could show, it's one thing to say, okay, yeah, you're going to make a lot of money in this field, but what about the job potential? Well, it's still a growing field, actually. And this is right from the American Society of Mechanical Engineers. There's 277,000 jobs in 2014, and then from 10 years from now, it was predicted to grow to 290,000 and just keep increasing. Our society is never going to be in a lack for technology. So here's our summary. It's mechanical engineering, not only a fun profession, but it pays a lot. Okay, so I think here I'm going to turn it over to Dr. Baddour.
Well, I just wanted to show you a slide with some statistics from the Bureau of Labor and Statistics and Employment. And on the left-hand side, it's showing you all the various types of engineering disciplines and the projected new jobs up to 2026. So just for the total engineers, you can see that number, the 139,000 new jobs predicted. And specifically, if we're looking at mechanical engineers, they're the second in line with job growth compared to other engineering disciplines. So there's really a good future for mechanical engineers. And if you're curious where you might be working in the future if you do become an engineer, on the right-hand side, this is still from the US Bureau of Labor and Statistics. just showing you a little bit the breakdown of employment for engineers. Top employers are in the manufacturing realm. You know, we have some engineering services, that could be some consulting, you know, federal, and so on. But really the top is indeed manufacturing. So that kind of sums up those statistics to give you a global overview a bit. Back to you, Ed.
I think this is you as well, Carole.
Oh, is this me as well? Okay.
Okay.
Okay, I'll continue then. In terms of what can Wilkes offer you for mechanical engineering, there's a lot of things that makes us a little bit different. So I'll just start from the top. This is kind of these little circles showing you various things. So the number one thing I would like to mention is we are an ABET accredited program. And that's a very important thing on the long run for becoming a professional engineer and coming from an ABET accredited school. So we're continuously improving ourselves to maintain that accreditation and to grow our program. Also here at Wilkes in mechanical engineering, we really try to have some small class sizes. So the average can vary a little bit, but often it can be 20 to 30 students per class, and we try to keep that cap fairly low. In terms of our facilities and labs, we've had a lot of renovations recently with some new labs, and this is directly affecting the undergraduate experience at Wilkes, and we'll talk a little bit more about those labs a little bit further down in the presentation. We really try to focus on hands-on experiences as well. So if you're a student coming to us in mechanical engineering at Wilkes, you're not always sitting in class just listening to a professor. You're actually getting active, going into the lab, doing experiments yourself on pieces of equipment that you are actually touching and using and not watching somebody do for you. So these hands-on experiences really benefit you on the long run in your career. In terms of the faculty, we have two of my colleagues here today with us, and you're not meeting everybody, but we are very accessible and caring in terms of faculty. So our doors are open. You can easily access us even sometimes outside office hours. So having faculty that cares can make a big difference in your experience. We are having a lot of co-ops and internship, and Dr. Bednarz will talk about a little bit about this later on. So sometimes you can, in terms of a co-op, replace a technical elective and have some real life industrial experience to replace a course. Or if you're doing some internships maybe in the summer, we always suggest to do that. So we have the tools to help you with those co-ops and internships. And one more thing is that we do have student chapters for various societies that are active. So PSP, ASME, ASHRAE, SWE, and so on. So our students are actively involved outside of the classroom for various activities. I think that sums up a little bit this slide. So Dr. Bednarz, back to you.
Okay, thank you, Carole. So what's our philosophy, at Wilkes Engineering? So engineering is the practical application of science for the benefit of mankind. There's a lot of different definitions for engineering, but I personally like this one the best. That science likes to discover for the sake of discovery. And that's great. We need scientists of the world. We need to know how the universe works. But at the end of the day, engineers say, okay, how do we take this technology and make someone's life better? How do we improve energy and transportation and communication? So, everything that you use on a day-to-day basis, that's engineering. You're driving around and your computers and the internet, and engineers made that happen. So that's what engineering is. I think that most students, they've perhaps were interested in engineering in high school. Maybe they entered engineering through one of two paths. They were practical, the quote gearhead, or theoretical, the quote book smart. And you're like, wow, I'm really good at math and calculus, and this seems like a fun field. Or you always love to tinker on cars and build stuff around the house. And you're like, yeah, this sounds like a good field. our goal is to bridge the gap between the two, just like Dr. Baddour was saying. And our curriculum is structured that way, that we have the theory in fluid mechanics that Dr. Ghamari will teach, but then he's going to have you work on the wind tunnel and actually touch, a huge wind tunnel the size of a room and create, take experiments and data and analyze it. So truly successful engineers can perform the theoretical analysis, but also be hands-on in order to get the tasks accomplished. And so that's our goal, is to prepare our students for the real world. And depending on their actual pace of work, they may be asked to lean more towards one or the other, but we think that you're most marketable when you have the balance, when you could show, yes, I have all this theory behind me and I understand the fundamentals of engineering, but hey, look what I built in my senior project and look what I built on just for fun. That's very marketable to show potential employers. So our goal is to inspire our students to invent, create, and excel in their life after Wilkes. So kind of showcasing again, we like to brag about what we do at Wilkes. It's a great place to work and be a part of, and we hope that you choose to come here. But this is from a third-party ranking. This is The Economist. They had their first ever college rankings, and basically they wanted to show expected student earning versus median earning after college. And this was a nationwide study they performed. And Wilkes actually ranked 25 out of 1,200 colleges nationwide. So in general, Wilkes can take students with a lower earning potential based on economic or academic background and help them find well-paying jobs. And not too shabby who we beat out at number 26. I don't know if you ever heard of the MIT school. I think they're up in Massachusetts or something. Okay, so now we're going to talk about our curriculum. And I believe I'm going to pass this back to Dr. Baddour.
Okay, so just a brief introduction before we go into details of our curriculum and the courses that you would be taking here as a student. Because we are ABET accredited, we have some very specific student outcomes that we attain via our curriculum. And these student outcomes really are what give you the tools and the background that you need to become a good engineer upon graduation. And just briefly, just to give you a feel of what are these outcomes that we will meet in the curriculum, there's 7 of them, very specific, each building on the previous one and just adding on. So foundation is, involving math and science and solving complex problems. Design, creating solutions within some constraints. Communication, the communication outcome is very, very important. Just being able to communicate verbally or orally your ideas, your thoughts, that's extremely important as an engineer. Number 4, ethics and professionalism. So we do emphasize doing the right thing. Teamwork, an engineer, yes, it's important to know how to work alone, but it's as important to know how to work within a team, because often engineers are part of a larger team. So we'll teach you how to use your individual strength and bring that together into a team. Number 6 is related to experimentation. So this is related to the hands-on, gathering data, analyzing, drawing conclusions. And last but not least is how to continuously seek that new knowledge. So you apply some new knowledge and are able to deal with new situations fluidly. So these 7 outcomes are addressed in the curriculum over 4 years. And then Dr. Bednarz, if you want to go to the next one, thank you. Globally, also we have some program educational objectives that are achieved throughout the curriculum. So these specifically is by the time you graduate from our program, within a few years that you start your employment, you'll be able to show the following outcomes. So they're mainly related to competency and professionalism, related to design, implementing solutions and processes, being part of a collaborative and interdisciplinary team. That was number 3. And number 4 is, again, communicating effectively. So these are our global program educational objectives. Back to you, Dr. Bednarz.
Okay, I think Dr. Ghamari is going to chime in here.
Yes. So the curriculum here is, well, you learn about the outcomes, the ABET outcomes, those 7 outcomes. The curriculum is designed in such a way to serve those outcomes. And this curriculum has been, it is not very rigid. We constantly work on that. We try to kind of, keep the curriculum very fluid every year. We may add new content because we want to, keep up with the technology pace if there is something new in the market. So we try to kind of add new flavors to the curriculum. So if you look at it, it's like any other engineering program. It's 4 years, 8 semesters. The first 2 semesters are basically focusing on basic foundation and math, physics, and science. It's actually the same courses and the same content for mechanical engineering, electrical engineering, environmental engineering, and engineering management. So they all take the same courses. You'll make a lot of friends actually among engineering program. And because of that, it's not really necessary if you haven't made your mind and if you're not 100% sure if you want to be mechanical engineering or something else, that's okay. The first year is basically the same. And then when you go to the second year, your 3rd semester, you begin to kind of, get your feet a little bit wet by taking more technical courses. The 3rd semester is the fall of your sophomore year. Is still a lot of, foundational engineering courses like circuits, both mechanical and electrical students take it, but you also take statics. And if you look at the 4th semester, it's almost purely mechanical engineering courses, mechatronics, strength, material, dynamics. So by 4th semester, you should have made your mind. Again, until the 3rd semester, you probably can still have some doubt. There is a little bit of kind of, leeway to switch to a different major. And that's a good thing. You can see different people, you make a lot of friends, you can talk with different professors, see the community, and do a little bit more in-depth research about what you want to do in future. But by the 4th semester, hopefully you will have made your mind. If you haven't already, a lot of students come to the program and from day 1, they exactly know what they want to do. They know what they want to be in future, but people are different. It's okay, to try different things. The 3rd semester, it's pretty much, I would say, the toughest year. We have tried to move. I told you the curriculum is very fluid here. We have tried to kind of move some courses around a little bit. And the reason is, if you look at the 4th year, we have the senior design. It's a capstone project. It's a hallmark of our program. It's a very important component. The students begin from A to Z of a project, from market research, preliminary design, detailed design, making a prototype, testing. And for that, we want them to be prepared. That's why we try to move some of the courses back to the 3rd year. That's why 3rd year, it's a lot of technical content. But the benefit of that is that at the beginning of the 4th year, when they get into their senior design project, I believe that they are more prepared compared to other senior students in other colleges. They have a lot of tools. It also provides them with them a lot of flexibility, a lot of time to work on the project. Aside from all of these departmental courses, we also have 4 technical electives. Technical electives are still courses that are offered in the department, but we don't enforce any specific course based on your interest. If you are more interested in a certain area, let's say in material science, or if you are interested in thermal fluid area, we offer multiple different courses every semester, and you can pick from them. You can try one course from every area to taste them if you want. You can specifically be focused. We have students who are into manufacturing, for example. They take courses in material, they take courses in electromechanical system, microfabrication. We offer those courses. They take courses in nanomaterial with Dr. Baddour, for example, Or we have students who like more of a thermal fluid. They like to work in the wind tunnel. They like fluid mechanics simulation. They take courses in, we offer courses in gas turbine, air conditioning. So these are different areas. So that's an opportunity to become a little bit more specialized and brag about something in your resume, especially if you are interested in a certain direction of the market. We also have co-op, which I believe Dr. Bednarz will talk about. So for co-ops, you basically, as you, during one of the semesters, you can go and work for a company. You will be paid by the company, and we try to kind of, incentivize that. And as a matter of fact, you can take, you can count the co-op as 2 of those technical electives. So see what the benefit is. You work for a company, you gain some experience, you get a lot of training. You are being paid by the company, and at the same time, you can satisfy up to 6 credits. That's 2 3-credit courses of your technical electives. That's what we really value here in the mechanical engineering department. Overall, you will be taking 130 credits. Around 30 credits are general education courses, which are philosophy, history. There are certain categories that you have to satisfy. Here is a flow chart that you can see. There are 3 different colors. You probably can guess that those in purple, the majority of courses are departmental courses. Those in green are math, physics, and science courses. They are basically math and physics, actually. And those in light orange are gen eds. So you see the gen eds, we just show gen eds because for some of them, you have a lot of flexibility to pick among a variety of courses that range from history, psychology, economy. And you can take 2 in a semester based on the schedule. But for the departmental courses, there is a little bit of flexibility, but you said there are these arrows that kind of connect them. The solid arrows here mean that they are sign of prerequisite. It means that if 2 courses are attached together with the solid arrow, you cannot take a course in the downstream where the arrowhead points until it has satisfied the course on the upstream or courses on the upstream. But if they are attached or connected using one of the dashed lines, that means that it's a core requisite that says that you can course in the downstream as long as you have already satisfied the course in the upstream, or as long as you take the course in the upstream at the same time. So that's the meaning of a core requisite. And that's because you want to make sure that you have the basic foundation as you move on. So you build up different skills, and that's how this curriculum is designed. So this is for mechanical engineering. The next slide, I believe, is for engineering management. We also offer engineering management. It's a different program in mechanical engineering. It's actually that gears towards managing engineering projects. If you look at it, I told you the first 2 semesters are 100% identical, pretty much. It's the same courses. The 3rd semester is very similar to mechanical engineering, but things from the 4th semester begin to change a little bit. And again, the reason is that in engineering management, you still learn about technical aspects of mechanical engineering. You are supposed to know about strength of material, heat transfer, material science, the basic foundation you need to know, because how could you manage a project if you don't know what's happening in that? So that's why we try to kind of provide in the first 2 years. But then in the 3rd and 4th semester, there is a lot of focus on management and business and finance aspect of projects. So it's similar to industrial engineering. And if you remember one of the earliest slides Dr. Baddour went over about the projected job numbers in the market, number 1 was civil engineering, number 2 was mechanical, number 3 was industrial engineering. So the mechanical industrial combined, they will actually create and need more job than any other engineering major. And engineering management in that sense is very similar to industrial engineering. It teaches you a lot about planning project, controlling project, doing analysis, financing projects. So anything that if you're interested in the managerial part of the industry, that's probably one of the best choices. I think the next slide, so and here is the curriculum for that. Well, you learned about all of the The basics are the same with the mechanical. The purple ones are departmental, and you know about the arrows. Again, the first 2 years are very similar to mechanical engineering, but then the last 2 years, you see there's a lot of EGM, engineering management courses, and there's a lot of, for example, finance and economy courses that you can take that will kind of shift the focus towards the managing aspect of engineering projects. I think it's back to you, Ed.
Okay, so now we're going to talk a little about our mentorship and introduce more of our faculty and staff. So what makes Wilkes different? And it may seem like a cliche, but we truly mean it from the bottom of our heart. We are faculty that cares. And we can say that because we are primarily a teaching school where undergraduate education is emphasized. There are other schools around the country, and even my graduate school, where the master's program, the PhD program, research, that's emphasized above everything else. And it's almost a penalty. I hate to say that but some professors nationwide look at it as a penalty to have to teach courses. They're like, oh, I'd rather be doing research or writing grants or publications and conferences. We do all that, and we're going to talk about that, but our main focus and where we spend the majority of our day is preparing for lectures, interacting with students, actually standing in front of the classroom teaching. We don't rely just on TAs to teach courses. The PhD professors are the ones actually teaching the courses. In addition to that, we learn about our students. We get to know them. We get to know them on a personal basis. We see them in a hall. We say, hi, Joe. Hi, Sally. How are you? They're open to come to our office. We give them real world advice, how to prepare them for going into industry or other careers, prepare them for graduate school. So, we truly pride ourselves on offering this hands-on experience and really getting to know our students. And there's a great brochure. I won't cover everything, but I think the quote with my colleague, Dr. Ghamari, shows the whole story. Here, professors get to know you. It's not just getting to know your name. So yeah, we know who Rich is, but we know who he is as a person. He feels comfortable to come to us and say, okay, I'm considering this job prospect, or I'm considering this graduate school, and what is your opinion? He trusts us enough to really ask us, and we do our best to help our students. We have dedicated faculty, real world experience. We're going to talk about our labs, internships, and so forth. So here's our department, and basically, mechanical engineering is actually a pretty broad field. There's a lot of different aspects, and I think Dr. Ghamari did a good job touching on them. His expertise is in the thermal fluids section, so he teaches thermodynamics, fluid dynamics, heat transfer. My expertise is in mechanical design, solid mechanics. So I teach the machine design courses, or right now I'm the coordinator for senior projects. And then Dr. Baddour, her expertise is in nanotechnology, nanomaterials. She teaches manufacturing courses. So we have a nice overlap and a nice diversity within our department. Here's our chair, Dr. Castahome. Here's our administrative assistant, Mrs. Lisa Colavetti. She does a fantastic job keeping our department flowing. Here's Mr. Mitch Adams. He's down in the machine shop. So our students get a lot of hands-on experience working with milling machines and lathe and cutting, so it kind of just emphasizes that the hands-on aspect of our curriculum that we pride ourselves in. And Mitch, he not only runs the machine shop, but he's also a teacher himself. He actually helps the students. And if they come to him with a part they need for their senior project, they don't just hand him the part and walk away and then come back and pick it up. He sits with them, teaches them, and says, okay, no, this is how you safely use this machine, and this is how you operate it, and this is how you make it on your own. So, it's a great aspect of our curriculum. Just emphasizing on this slide happens to be a lot of our senior faculty that have been here 30 some years or so. Dr. Garishi, Dr. Kaleem, Dr. Razavi, they're all mentors of mine. And then we have Mr. Greiner. He's really spearheading the effort in our engineering management program, as well as teaching other courses along the way with statics and strength materials. Dr. Mu, he runs our additive manufacturing lab, our 3D printing facility. So that's a great new facility that we got recently in the last few years. We want to try to keep cutting edge with technology, and 3D printing is definitely one of those emerging technologies worldwide. So we want to get a nice foot in the door there. Dr. Zhu, he's our robotics expert. That's another emerging field, continuing emerging field. Mechatronics, robotics, it's sort of electrical engineering, mechanical engineering crossover there. Robotics happens to fall in mechanical engineering, but a lot of our students, they have interest in that aspect. So it gives them experience to not only have a mechanical engineering background, but some electrical engineering background as well. And then lastly, our dean for the College of Science and Engineering is Dr. Murphy. All right, so we've talked a lot about our hands-on experience. Just want to highlight some of our labs. Our small class size that Dr. Baddour mentioned early on is what allows for this hands-on experience. I know it, personally, I know it from other schools, talking with students and talking to the friends that have gone to bigger schools nationwide. And I said, oh yeah, when, at Wilkes, we allow the students to actually work on that wind tunnel. You could see the wind tunnel pictured, it's about the size of a room. And other places, they said, no, we're not allowed to touch it. Maybe a TA touches it and we watch from across the room. Your students are allowed to touch that and work on it? Yeah, we trust them with it. You know, we guide them and help them, but that, you know, we pride them that they leave here with the skills to actually do this in the real world. So we have vibrations lab, mechanical design lab, microfabrication, nanofabrication, mechatronics, heat transfer. You know, it's just a wide variety of labs we have. And we really invest in our facilities to really keep our labs up to date and state of the art. So here's a view of the robotics lab, Dr. Zhu's lab that we mentioned. And students really have a lot of fun in here. Robotics is a required course, but they can take a technical elective, as Dr. Ghamari had mentioned, if they want to take even more in-depth with PLC, CNC, and so forth. So we do have a graduate program as well. We have master's students in the mechanical engineering program. So I believe all three of us presenting today have worked with graduate students in the past. We've helped them earn their master's degree, presented with them at conferences, and published papers along with them. So, and that's fairly typical to a lot of universities that have graduate programs. But I want to highlight what we do differently here is that we like to involve students at the undergraduate level and let them be involved in research with PhD professors. And I'm not saying that no school nationwide does it, but it's a somewhat rare thing, I believe. That we like to work with our students as undergraduates, either on independent study or even through senior projects and what have you. Here's one of my research areas of a force transducer on a simulated Army bridge using strain gauges. And here's a typical research lab. This is my inverse problems lab, and this was at a particularly busy point in the semester. We had some senior projects teams working together, and we had independent study research going on, as well as you can kind of see on the right here, there's some toys. You're like, well, why is there toys in your lab? We also have outreach events with middle school and high school kids to get them interested in engineering. So we let them build with Connects and twister tracks and other fun activities to say, yeah, this is engineering. You know, you're building something new. Okay, so now we're gonna shift into our senior capstone project and cooperative education and internships. So here's our poster for the most recent senior projects event in the spring. And this is our Super Bowl. This is our mechanical engineering Super Bowl. You know, these students, they've not only been working for 4 years towards earning their bachelor's degree, but they spent a full year on one specific project in small groups. So they start their project in the fall, and they work closely with a dedicated faculty advisor where they meet weekly and work with each other in order to finalize the design in the fall. Then in the spring, they continue the project and work on physically building the prototype and testing it and seeing if it works like they thought it would work. So, and all while working directly with the faculty advisor and getting that mentorship and experience from the faculty member. They're allowed to create their own logos, so you can see their personality shows through. And it's just a great experience for everybody in our department to be involved with. You know, everyone in our department, our advisors, the teams, and then just to watch them present is such a great event. So here's our link to our senior projects website, wilkes.edu/ME senior projects. And just to highlight a few projects, this was an adjustable wheelchair project where myself and my wife, Heather, and students, we actually worked together throughout the 2 semesters, and then we decided to file for a patent. So currently we hold a patent, and we're all equal partners, and our goal is to sell it to a company and see it built. So you know, just want to highlight that sometimes these senior projects can turn into patents or even companies. There's another senior projects team I'm going to highlight later on. Here's a senior project that working with real world customers. You know, so we have a lot of senior projects where we'll work with local industry, and they'll get experience working with customers and going to the facilities. This was more of kind of an outreach senior project, I guess you'd say. It was working for a local church where they were converting an old church into a new parish center. So the students got to do acoustics analysis and mechanical analysis and vibrations testing on the new benches they created. So, you know, that was a great experience. Here was kind of a more fun senior project, and we like to let the senior projects team form their own project organically. We think that's a good philosophy. That way we let them be creative. We don't want to just assign them a team and assign them an advisor and assign them a project. You know, we do have projects available that we say, oh, well, you know, here's an idea if you want to jump on it. But most of the time we let the students come up with their own. So this team, you know, and they're all 21, but they came up with an idea to build an automated drink mixer for a bar. So a bartender could be able to just punch in a specific drink, and they would have all the bottles preloaded, and it would do all the mixing and automate it. So that was kind of a fun project to be involved in. We also have another fun project, the Rube Goldberg machine, where it's a very outlandish way to do a simple task. You know, you may have seen the old Rube Goldberg comics from the 1930s. And every year they have a nationwide competition. So we had a team that actually won the online People's Choice Award in 2017. So that was a great project to see. Here was a project I mentioned. One of the aspects of engineering is energy conversion. How do you generate energy, right? It's a huge deal. This team, and again, they came up with this idea on their own, that they said, well, if we hang a really heavy falling weight from a tree and your cell phone's dead, you can charge your cell phone enough to make an emergency call. So you could turn gravitational potential energy into electrical energy. So this is a great multidiscipline project where we had electrical engineers working with mechanical engineers. And again, the students came up with this on their own. So fantastic project. Kraken Board Sports, this team, they were driven right from the start. They started out as a machine design project, a junior level project, and then they decided to turn to a senior project, and now they have their own company. So basically they came up with a way to wakeboard without a boat and snowboard without hills. So they created this winch system, and they go up and down the East Coast. I think they were just in South Carolina, Florida, last year selling their products, and you know, they have a great time. So here's an example of you know, them doing something that they love and passionate about. Here's a couple projects to highlight. This team, they wanted to build a pumpkin chunker, so we got to launch pumpkins across the greenway. Public safety was sort of walking around questioning what we were doing, but I said it's for engineering. So. And then the one on the right, this is another fantastic project. They built a high lift dump trailer to scale. So basically they wanted a way to lift mulch into a yard with a fence into it, or for roofers to bring materials up to a higher level. And typically the projects, we like to limit their budget to about $500. So it just gives them real world constraints, because engineers don't have infinite resources, infinite time, infinite budget. So, most of these projects that I showcased, they were able to do it for a $500 budget. When this team proposed the idea to us, we knew right off the bat that it was going to cost much, much more, probably an order of magnitude more than that. And we said, hey, if you want to pursue this project, you better reach out and find a sponsor. And they did. They were driven, they were goal-oriented, and they found a local sponsor to help donate the material, help with the fabrication, but they were there building it alongside the other company, so that was a great project to be involved in. Here's another patent, different than the adjustable wheelchair, but again, a project I worked on with students and my wife. It was for pressure redistribution system. If a patient who is paralyzed or partially paralyzed and they're sitting in one corner of a chair too long, they may develop a pressure ulcer. So we developed a way to measure if they need to have their weight shifted, and it would alert a caregiver, or maybe it would inflate the bladder and do it automatically. So this was kind of an example of a bioengineering project. So we actually do have bioengineering masters at Wilkes. So we have a lot of students that they'll start out with a mechanical engineering undergraduate degree and then go into the bioengineering master's program. Another one is 3D printers. Students actually built their own liquid resin 3D printer. So that was phenomenal. It's amazing what these students will come up with. And I love highlighting what students have come up with on their own. Just showing that they have such innovation and such creativity. And here's just kind of a snapshot of what the senior projects presentation would look like. They'll start out as freshmen with, very timid and really afraid to present in a small classroom. And then by their senior year, they're presenting in Stark 101, which can hold, several hundred people. And, they're confidently walking around and showing their PowerPoint and saying, hey, look what we built. And they're very proud of it. And it's such a wonderful event to be a part of. I know we had talked about our co-op experience. We definitely encourage students to get some sort of engineering experience with company while they're in school. It really helps to differentiate them on their resume when they're applying to jobs. Or a lot of times they'll start working for a company while they're in school, work their junior year, senior year, and by the time they graduate, their company will offer them a job and say, well, we've already trained you, we like you, you want to just work here after graduation. So that happens a lot. Now, students are encouraged to somehow work for a company, and we give them the option. If they, like Dr. Ghamari was saying, they can take it for credit if they choose to. So basically we turn it into an academic experience. They have to write bi-weekly reports, do a presentation at the end, do a final report. Or if they want to just work for the company, we call it an internship instead of a co-op. And that's not taken for credit. But either way, students are paid. I know some other majors, internships, co-ops are expected to be unpaid. But our students definitely make pretty good money, $15, $20 an hour as students. And here's just, a snapshot of some companies our students have worked for. A lot of great companies in this local area, the Scranton, Wilkes-Barre, Hazleton area, or some students, they may live down in the Allentown, Philly area and get an internship co-op there over the summer while they're home. And I can't talk about co-ops and internship without highlighting Mrs. Sharon Castano. She works direct on the right in this picture. She works with all students at Wilkes, but I think she has a special place in her heart for mechanical engineering students. She works with them to help them build their resume. She talks about interview skills. These real world skills. Okay, how do you talk to companies that are trying to hire you? And how do you get them to hire you? And here's her shown with a local radio celebrity from 98.5 KRZ. Wrapping up just a few slides, and then we'll have some time for questions. Here's collaboration with a local company. this is what I was saying, that we like to involve our undergrads in not only research, but actually helping local companies. So this was a great partnership between Wilkes University, Mountain Productions, which was a local company in Wilkes-Barre, as well as the Ben Franklin Institute, who helped to partially fund the endeavor. And this company, Mountain Productions, they provide flooring for large outdoor events. You know, think concerts, outdoor graduations, but then when they get their panels back, they're dirty and they need to be washed. So they were hand washing every panel, and it was taking them several weeks to a couple months, depending on the size of the job they did. So our students, they came up with basically a car wash system for these panels, an automated car wash system, and just greatly reduced the time and labor. So saved the company, you know, a lot of money, and you know, great experience for them. Something very unique they could put on their resume that, you know, no other student would have. Here's highlighting a couple of our alumni, Adam and Andrew. They currently work at Toyota in Michigan. So, you know, I know Adam personally. He was my student, and I helped mentor him. And I know Dr. Ghamari, Dr. Baddour did as well. And he had it as his goal that he always wanted to work for a car company. And, you know, we don't laugh off goals like that. We're like, oh, it's too hard, it's too competitive. No, he said, yeah, go for it. You could do it. And sure enough, he studied hard, worked hard in school, and now he's working for Toyota, and he loves it. Okay, so now we're going to talk about ABET and beyond the classroom. So I know I'm just going to wrap up in a couple minutes. I know Dr. Baddour had mentioned the various student chapters of professional organizations we have here. We have ASME with various events. They have a yearly car show. We have speakers come through, regional conferences, SWE, ASHRAE, you know, just a lot of different things that students could get involved with in engineering as students. And, you know, especially when we have local events, they can meet students from other schools and network and make new friends. And, you know, it's just a great opportunity for them. I mentioned our outreach events. Here's, we like to showcase science and engineering to local fifth graders through Adventures in Science, Women Empowered by Science, you know, a lot of different events. So we let them build their own Goldberg machine, or build twister tracks or marble run, and, you know, just show them, hey, engineering is fun. You get to create, you get to build, you get to be hands-on. All right, so in conclusion, mechanical engineering, we all believe it's a very rewarding career. It's a fun career. And specifically here at Wilkes, we believe we're giving you the skills necessary to be a successful engineer. How is Wilkes different? We offer students a hands-on education, caring faculty, and industry connections. And then here's a quote from Steve Wozniak. He's the other Steve at Apple. You know, he was the engineer behind the scenes working with Steve Jobs. I hope you'll be as lucky as I am. The world needs inventors, great ones. You can be one. If you love what you do and are willing to do what it takes, it's within your reach. And it'll be worth every minute you spend alone at night thinking and thinking about what it is you want to design or build. It'll be worth it, I promise. All right, so that, I think we have some time to open the floor for any specific questions. Myself, Dr. Baddour, Dr. Ghamari would love to answer them. So thank you for attending our virtual presentation.
We have one question, actually, Amy, I believe, when I was talking about the curriculum and co-op. And you may have answered that question, but here's the question one more time for everyone else. Amy asked that, let me pull up the question. During co-op, you are still taking a full semester of coursework, right?
Yes. Yeah, so that is a great question. So we typically like to limit students to how much they could work for a company. If they're working over the summer, they may, I'm just going to try to get back to our flow chart here. If they're working over the summer, they may work 40 hours at a company if they want. There we go. But if they're trying to do a co-op during the school year, we try to limit them to 10, 15, maybe even 20 hours a week, depending on what the rest of their workload works. But that seems to be doable. You know, for a lot of students. So it really is up to the student how much they want to work. But a lot of the local companies, they know the students are in school. So, you know, they're not trying to work them 5 days a week, 8, 9 hours a day. You know, they'll schedule their classes. They may only have classes on Monday, Wednesday, Friday. So maybe they'll work half a day Tuesday, half a day Thursday, or full day Tuesday, you know, depending on what the rest of their schedule looks like. But, you know, and a lot of students have other jobs anyway. You know, a lot of college students have part-time jobs at Burger King or Taco Bell or something. But we try to encourage them, get a meaningful job that you can put on your resume. You know, if you graduate with an engineering degree and all you have to put under work experience is fast food restaurants, a company may be a little hesitant to hire you. But, you know, even as freshmen or coming into their freshman year, if they can get a job at Home Depot or Lowe's, at least they're showing some hands-on experience in the engineering field, even though they're not doing engineering design, but they're at least around tools, hardware, stuff like that. So I think hopefully I answered the question. But yeah, they're not really expected to work, you know, hours and hours, maybe 10 to 20 hours a week while their school is in session during a semester. That would be typical.
I have also unmuted everyone. So in case you want to speak directly and ask your question, you just need to unmute yourself. So that option is available for whoever wants to directly ask question.
Are there any questions?
Hey, I have a question.
Mm-hmm.
Is there any like flexibility, like with your major in engineering, like is it possible to do like a minor, or is it going to be like very difficult to fit in time for that?
Yeah, we definitely we encourage minors for students. It's another thing they could differentiate on their resume. There's some minors that are more in line with the engineering program. You know, physics is one that we see a lot of our students getting a minor in. They may only have to take 2 or 3 extra courses because they're already required to take 2 base level physics courses as part of our degree. Dr. Baddour, Dr. Ghamari, is there other minors that you've seen throughout your advisees? Dr. Baddour, I think you're muted.
It helps if I unmute myself.
Yeah.
The engineering management minor, I believe I've seen a few times as well. That can be a popular one. And I've had some students that even take a minor completely unrelated to engineering. I had a student who's taking a minor in art because she felt that the art balanced well the engineering. So it really depends on the minor and how it kind of fits in on the schedule, but we do encourage it.
We also have a couple of my advisees. They are doing a minor in physics. We have physics department, and since it's very close to engineering, and it's also easy because students can kind of, you know, take courses which are required for mechanical engineering, but at the same time, they already satisfy some of the requirement for physics minor. So by taking maybe another like 3 or 4 extra courses, they can satisfy ME, like technical elective. So it doesn't really cost them too much time or even an extra semester. So by the end of the 4th year, they can also, you know, have a minor. Computer science has also minor. I had one student who was interested, and that they kind of give them really some competitive edge in terms of some programming skills, especially now data science, you know, algorithm is a hot topic. So they can also, you know, sharpen their skill through those minors too.
We've also seen students do double major in mechanical engineering and electrical engineering. You can't get a minor in EE, but for those that want to invest the extra time and they say, no, this is my career path, I definitely want to be or have the option to work at a company that does either or both, Maybe it'll take an extra year or year and a half, depending on how they plan the rest of it. But I know currently we have 3 seniors that are taking dual mechanical engineering senior projects and electrical engineering senior projects. And I believe they're all in their 5th year. So that's another option we've seen. Yeah, thank you for the question, William. Anybody else have any questions they would like to add? Okay. I guess you could always.
Yeah, I was going to say it's right at noon. So if no one has any question, we can adjourn this meeting and say goodbye. What do you think, Ed?
Yeah, I was going to say, if anyone wants to reach out to us, our emails, I was just going to put them back up on the screen so I don't have to read them. Let me share real quick one more time. Okay, so my email is edward.bednarz@wilkstudy.edu, Carole Baddour @wilkstudy.edu, Mohsen Ghamari @wilkstudy.edu, or feel free to reach out to our chair, Dr. Castahone, our administrative assistant, Ms. Colavetti, or Dr. Murthy Ardeen. So all our email addresses are up here on the screen. We'd be happy to answer any specific questions about our program. And yeah, on behalf of Dr. Ghamari, Dr. Baddour, thank you for attending, and have a great day, everybody. Okay, thank you.
Thank you.
Thank you.